Hi, this is Presh Talwalkar. How many squares are in this picture? Give this problem a try, and when you're ready, keep watching the video for the solution. One way to solve this problem is by counting the number of squares very carefully. We'll remove the two squares that are in the middle to be left with a 4x4 grid. Now we'll count the number of squares of different sizes. There's exactly one square that's 4x4, that's the big square. And then we'll count down the number of squares of smaller sizes. The number of 3x3 squares can be found that there are 2 squares per row, and we can count this for 2 different rows. So there are 2 times 2 or 4 different squares of 3x3 size. How many 2x2 squares are there? In a given row, we can place 3 2x2 squares. And there are 3 different rows that we can create squares, so there will be 3 times 3, which is 9 2x2 squares. Finally, we count the number of 1x1 squares. There are 4 different squares in a row, and we're going to have 4 different rows that we can do this. So there will be 4 times 4, which equals 16 1x1 squares. We now place the 2 squares in the middle back together, and we count the number of more squares that they add. The number of big squares that they add in the middle will be equal to 2. And now they'll add some small squares in the middle. Each of these squares is going to contribute 4 more small squares, and there are 2 of these, so this will contribute 8 more squares in total. We add up all of these numbers, and we've counted that there are 40 squares in this picture. Did you figure it out? Now there's a shortcut we could use if we're going to do problems like this. If you have an n by n grid, there will be 1 squared plus 2 squared plus all the way up to n squared number of squares. We found this already, that the number of 4x4 squares was 1, which equals 1 squared. The number of 3x3 squares was 4, which equals 2 squared. The number of 2x2 squares, remember there were 9 because there were 3 squares per row and 3 rows. And the number of 1x1 squares was 16 because there were 4 per row and there were 4 rows. We could have started out by counting this without even doing the count of the squares, just using this formula. And then we would have had to add on the number of squares created by the squares in the middle, which would have been 10, and that would have again got us to the answer 40. So you could intuitively see why this formula is true. You count the number of squares created per row and the number of rows you have. But let me just provide another proof. We'll use induction. So we'll assume the formula is true for n, and we'll prove it's true for n plus 1. So we have an n by n grid, and we're going to add on 1x1 squares on the side so that we have an n plus 1 times n plus 1 grid. By the induction hypothesis, the n by n grid has a total number of hidden squares of 1 squared plus 2 squared all the way up to n squared number of squares. So now we need to see the number of new squares we can create by the squares we've added on. We first count the number of 1x1 squares we've added on. You can count this by saying there's n plus 1 squared minus n squared, or 2n plus 1 squares. Another way to see this is you're adding on n plus 1 squares to the row, n plus 1 to the column, but the one in the corner is going to be mutual. So you have 2n plus 2 minus 1, which is again equal to 2n plus 1. Now you want to count the number of 2x2 squares that you can create. This will be 2 fewer, and the number of 3x3 squares will also be 2 fewer. And this pattern continues, and you can add on exactly 1 square that's size n plus 1 by n plus 1. So the total number of squares we can add on is the sum of the odd numbers up to 2n plus 1, and that's a well-known formula of n plus 1 squared. So we've added on a total number of n plus 1 squared number of squares. So in total, in an n plus 1 times n plus 1 grid, we have the same formula plus n plus 1 squared, and that completes the induction. Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.